Hello, I'm Howard. I've worked in UK railway engineering for nearly 20 years in everything from maintenance, renewals, and fault response to project work, design work, and management. I wanted to talk today about Watch Dogs Legion, which is a game I've only recently played but has been suggested several times on the channel. So, what I do in these reviews is I look at the railway infrastructure, the signalling, the tracks, the points, and everything else, and I see what the developers got right, what they got wrong, what they could have done better, and give a bit of a review on it. It's never just a dig at the game. I know that not every game needs a hyper realistic railway, but it gives me an opportunity to talk about some of the real design principles that go into making the real railway look realistic in the game. And today I'm going to start with signaling. This is a position light signal. It's quite realistic looking. It's got the sort of correct arrangement of LED lights there. You can tell they're LED by that sort of honeycomb structure behind the lens. The bottom two being red and the diagonal pair being white, which I'll look at here. So here I've got a Dorman position light signal LED variant. It works on 110 volts AC and operating current's about 300 milliamps, zero point 0.3 of an amp. So normal operation, these are your reds. So at stop, both these two bottom aspects will be lit up red. And this is what you call your pivot light. So this can be red or white. Because it's LED, it simply changes colours. And then these two go to white when it's at proceed, so to call the train on into the next section. So proceed when these two are white and stop when these two are red. So let's turn it round and open it up. These are heavy, these things. I can just about get it into the camera shot. There we go. Aha. Lockpicks, great for when you forget your key. Let's open it up. You've got to separate the back from the front because the front is essentially just a cover. Here we go. Got the cover off. That also is the fixing point. So covering the wiring terminal block is the diagram that tells the signaling technician how to wire up the signal for different configurations. So you remove one of the wires when it's a solid state interlocking area. You can see there's 6 cable terminations and there's these links. These provide a disconnection point because sometimes you'll need to replace the cable and you'll have to take off some of the wires and reinstall it. These are very reliable signals. It's very rare one of these goes wrong, but when it does, I've seen it once or twice. It tends to be the pivot light that goes because the pivot light is on the most out of all the aspects because it's on at red and it's on when it's at proceed. It has the most functions. So the thing that has the most functions tends to go wrong the most. And it's this one has been replaced a couple of times that I've seen. This one, the same arrangement as a real one that I've just shown you, but the cable termination box in this case appears to be on the back, and it looks much thinner and more lightweight than that beast that I just picked up and put on my knee. They're really quite heavy, solid metal. This one appears to be a bit lighter weight, a bit more modern. And this game is set in the year 2030, I believe, 2029, 2030. So Dorman may well be making um, things as lightweight and as slim as that in a couple of years' time. But you can see nice big aspects there, a bit bigger than the real one I just showed you. So that is a realistic design for 2030. I would probably expect to see position light signals looking a bit like this in 2030. That's no reason why not. The only issue I have with these is that these are for like call on and shunt moves, which typically will go off over a set of points or into a station platform. So a call on move would be where there's already a train in the platform or already a train into wherever it leads to, and this will be used to call the train past. And in this arrangement where it's 4 lines, you really wouldn't have a position light signal in the middle. You'd be much better off with a main signal in the middle here. So your typical red, yellow, and green aspect main signal. There's no it's good that they've put this signal in to show a bit of variety, but there's really no use for it in this manner. It could be used in conjunction with a main signal here, maybe, but it doesn't really perform its function. They're doing better off with a main signal, but good nonetheless. See the little sign underneath it, 9396, they've left that signal designation in, but in reality they'd all be different. That indicates that it should be a right-hand turnout, and this one should also be turning out to the right, again 9396, same signal number, but there's no turnout there. And further up from that last set of position light signals, there's some more. Once again, in the middle two lines, and here we are looking at a nice signal grouping on an overhead gantry. This is a realistic arrangement. So you've got the main signal there, which appears to be two aspects, but because it's LED, it's probably four. So you'll have the green at the top, the red at the bottom. Red is usually at the bottom because it's closest to the driver's eye for safety. So if the signal was on the floor, the top would probably be red. And then the LEDs can obviously change colours and give you a single or double yellow. So you can have a double yellow. In terms of restrictedness, green is the least restrictive, followed by double yellow, and then red. So this is a realistic sort of arrangement. You'd have a main signal, and then there's a shunt call-on signal there. It's only got the two white lights. So that's you can have two aspect arrangement or a three, depending on its use. And that square one above the top, that's also a signal. That's an alphanumeric route indicator, sometimes called a theatre, and that will have in it a letter or number or series of letters that will say to the driver where they're going. So you could have P1 in it for platform 1, P3 for platform 3. It could be UM for up main, it could be S for slow, but you would have some letter or number in there that gives the driver some advice on where he's going. Speed sign there. Good to have that on near the signal. So they've got this right in that the bottom number of a differential speed limit is always the higher. So the 60 on the bottom is exactly where it should be, and that would be for passenger services, postal trains, and stuff like that. And the 35 would be probably for freight or other categories of train. So variable speed limit there. You've got the same face in the other direction with the speed signs. It's got a theatre, a position light indicator with the two aspects, and a 2/4 aspect main. And that would be appropriate for this junction. You could have it going straight on, or the position light indicator could give you the turn off to the right. The gantry itself, the overhead span that you can walk across, very realistic. I've been up signal gantries like this in the past, where you can walk across the top, and because it's caged, because there's a cage around it, you don't need a three-person team for working at height. You can get away with two-person or even one there because you can't fall off because you're enclosed in a cage. So you don't need as much working at height equipment. So the fashion is either to put one of these cages around so that you don't have to work at height, or just to have no climbing whatsoever. We've got signals now that you install and they get replaced once every 10 years and they're maintenance free. So you remove the working at height safety element by having the signal maintenance free, and you don't even need to climb anymore. But this one, it appears you still do. The only thing I would say about that signal gantry is because the signals are below the floor of the basket, the floor of the cage, you're not actually going to be able to access them from that cage. So there's that, but almost totally correct. Here we have another type of signal, some good variety going on here. This is a three aspect main signal. It'll just be usual red, yellow, green arrangement with the red being the bottom aspect. Makes sense for where it is, although this sign here is indicating that there's a 25 mile an hour turn off just up there. And I've just come from that way and there wasn't. So it's nice they've put a speed board in, but it doesn't actually tell the driver anything of use. AWS, this is some British signalling, so good that it's here in London. This is the automatic warning system. So that it's a piece of equipment that tells the driver in low or even no visibility what the signal's doing. So back there in the middle of the tracks somewhere, there would be a big yellow permanent magnet, and there'd be an electromagnet tied to the green. So if the driver goes over the magnet when the signal is at caution or stop, he'll get a horn sound in his cab from the permanent magnet. The train will detect the permanent magnet and he'll get a horn. And he's got several seconds to acknowledge that before the train slams the brake on itself, because the driver might have missed the signal, and if the signal's at caution, it'll automatically anchor the brakes on. But if the signal's at green, it will sound a bell instead of a horn in the cab. It'll ring a bell and show a little yellow indication to tell the driver, crack on, it's safe to proceed. And that there with the black and white hatched little sticker on the front, that's actually, I'm pretty certain that's a signal post telephone. So I don't know who's using that. Maybe the Dutch giant, someone who's about 7 foot odd. It should be a bit further down the post, but that sort of black and white hatched little sticker on that box is usually indicates a signal post telephone. And this is almost certainly frequency track circuit equipment. This is very, very common to see. So you've got one cable attached to one rail and another cable attached to the other, positive and negative sides. And rather than just normal electricity voltage, this actually sends an audio frequency, a tuned frequency through the rails. And it does away with insulated joints. So with a DC track circuit, you have to have positive and negative voltages meeting each other at a joint to make a block section. This removes the necessity for joints by having different frequency tuned areas meeting each other. So in essence, it does away with the insulated joint and creates tuned zones to occupy each track circuit. The theory on this is quite complicated. They're quite simple to actually work on and set up and everything, but tracks frequency tuned zone area tracks are not the simplest thing to explain in a video. I might save that for another time. And this is hilarious. These are that is definitely a HW points machine, like 100%. Only they've made it tiny. It's like a little miniature version, and it's not near any points. So this is what would operate a switch or a set of points. There's a motor inside it and a circuit controller to give drive and detection and detect normal and reverse positions. So there's a whole load of equipment in there, but they've made it tiny. These machines are absolutely massive, and much bigger than they appear in the game. And there's no points here. Another signal here you can see in a bit better clarity. Oh, that red and white, it's on a box there, but that red and white checkered sort of little sticker there, that means limited clearance. So it means there's not much clearance for you to walk down the side of the railway there, so you better not go down there without a line blockage. They've put the points machines in the 10 foot in the middle of the tracks where they're not needed, and then the switches and crossings in this game don't have any points machines. So there are points machines in the game, but they're just not hooked up to anything. So the signalling portion of this game, they've got a good variety, some real signals, some realistic signal groups. The signals are vaguely in the right places. They've not got it perfect, but I'd go as far as to call it good. They've understood a lot of what they had to do with the signalling, and I don't actually know that you even come up to the railway in any missions, because there doesn't seem to be anything up here other than just the empty infrastructure. There's no like obvious missions or bandit camps or anything like that. So for them to have put that much effort into signaling is admirable. But this is where it starts to fall down. The track in this game, there's quite a few problems. The first thing that anybody who knows track will notice when they look at this is the gauge width. So the gauge is the distance between the left hand and right hand rails. So this is an enormously wide gauge, which I'm not discounting that in the future they might use wide gauge because it has its benefits. But in Britain currently we work with a 4 foot gauge, we call it. It's 1435 millimeters, 1435 millimeters in width. Normally some 1432 if it's vertical rail versus inclined rail, but generally speaking about that. But this really is massively wide gauge. As I say, there are benefits to having wide gauge. You get more stuff on the same train because the aisles are wider. There's more volume on your freight trains. There are negative aspects to it though, like it just takes up so much more space and so much more resources and materials. So let's have a look at the individual components. First thing, ballast. That's good. You need ballasted track. That's good to have. The rail looks. I couldn't really tell whether this was flat bottom or bull head design because normally on a flat bottom rail, the bottom section that sits on the base plates is usually significantly wider than the top. And in this case, it's the same width as the top. So the bottom portion of the rail is the same width as the top. It also doesn't sit on the base plate as it should. You can see that the rail's clipping through the sleeper here, and sits in the base plate inside these concrete sleepers. These are concrete sleepers. And the rail fastenings there, these are what are called SKL clips. These are a versatile and widely used fastening that are this sort of pretzel shaped clip with the screw holding them down. These are, like I say, versatile and widely used. If you need to bring the gauge in, you can use one type of SKL clip. If you need higher tensile strength to stiffen up the track for one reason or another, or take some of the stiffness out, you can adjust the amount of hold it has on the rail foot. This is okay. This is a catch pit, so you'll see there's some troughing lids coming away from this catch pit. What that catch pit is with the blue lid is it's an area where there's a pit that goes below the normal drainage level that collects all the silt and mud and debris that would otherwise clog up the drain. So in the bottom of that pit, it goes lower than the normal drain level, and you can empty out all the silt and stuff after a bit, and it just keeps the drains free of all the rubbish that gets in there. And they do have exactly these blue lids on the top. It's a little bit smaller than I'd have expected. The catch pits are usually a bit bigger, but they've modelled it quite well. That you do have them blue lids. The only other thing you can do where there's a catch pit between two tracks, sometimes you'd use round instead of square, because if there's a train on both sides, there's quite a lot of dynamic pressure on a catch pit that's square, and you can get side crush where the ballast, because it's under so much force, crushes the sides of a catch pit. But what you can do in tunnels, an area of limited clearance, is put a circular one in, a round one, a tube catch pit, and that tends to spread the force of the weight around it much better. A tube's a very strong shape compared to a square when it's resisting crushing. Here's another catch pit randomly placed against the rail that will get smashed to pieces by the flange of the wheel when it comes through. And some sleepers missing there as well. Should be one or two sleepers there that are hidden by that catch pit. And look, that's clipping through with the fastening coming up and clipping through the rail. Just unfortunate. They could have ironed that one out by probably affixing the bottom of the rail onto the top of the base plate, because it's supposed to hold the rail foot. Here we find some switches and crossings. A few issues here, some classic video game mistakes, to be expected, really. So the first thing they've not done is they've not planed down the rails to allow a smooth transition into the switch. It's just a big piece of rail that's going to direct a lot of force around it very quickly. The switch rail on this side is on the outside instead of the inside. The pair of switch rails should be on the inside of the switch, and they should be joined together by a stretcher bar. And the stretcher bar needs to maintain the distance between those rails to allow a gap at one side when the points are set one way, and a gap to appear at the other side when the points move over. Speaking of which, there isn't any point operating equipment, so they could have done with one of those tiny points machines from earlier and mounted it at the side of the track there at the toe of the switch, and that would probably have sufficed for a bit of point operating equipment. The old HW machine. There's no gap for the train to get through. If you trace where the train would actually go, it would never be able to turn right over that switch because the inner rail goes straight and the outer rail is in this case the switch rail. So a train would never actually be able to turn right round this switch. This crossing, if you imagine a train wheel is coming along through this crossing, it's just going to hit the other rail that's clipping through it and completely derail. So what you want here is a crossing with a crossing nose, what the Americans might call a frog, as well. This allows the passage of the train through the switch, and you'd probably put a check rail or a guard rail in as well to help direct the axle in the right direction. The concrete sleepers, they've not known what to do here, so they've just missed off the turnout sleepers entirely. They've not really known to make long timber sections and not have two lots of sleepers clipping through each other. They've done a variety of things actually in this game. In this location, they've just omitted the sleepers entirely from this line. So that right hand rail is not fastened down to anything. There's no stability. If a train tried to go through there, that right hand rail would just splay out and the train would fall into the switch. It would push the gauge, push the rails outwards, and just fall into the middle, and end up with its wheels in the ballast there. And what the heck is this? There's a sort of a ghost floating piece of concrete there. You see it? It's just sort of the concrete. If it was the predator, just sort of floating in the air there. It's very unusual. Another crossing here, but they've decided to overlay the sleepers into each other and make two rows of sleepers there instead of omitting them entirely. So they've not, a little bit of credit, they've not clipped the sleepers through each other. They've been very careful to not clip them through. So someone spent quite a lot of time making sure these sleepers don't clip, instead of simply making one long sleeper, which is the normal way to design a switch. Overhead lines. They've got plenty of overhead line structures in this game, but no overhead lines themselves. You can see they've got the overhead span there and all the brackets, quite realistic looking brackets, good looking structures, but no overhead lines. I'm not discounting that because it's 2030 and they might have found a more efficient way, and maybe overhead line became inefficient or too expensive, and they had to resort to other means. You can see that none of the locomotives and none of the carriages or anything in this game have any overhead line equipment. So when you have overhead lines, you've got to have the corresponding equipment on top. You would expect to see on top of the train a pantograph, which is the part that raises up when you're under overhead line sections and makes contact with the contact wire of the overhead lines, because the pantograph makes contact with the overhead line, and the electricity goes through the pantograph, through the train's motors, and powers the motors, and then comes back on a return path through the rails, the traction return path. But as you can see on this train, there's none of that equipment. Here we've got some different kit. You've got some wooden sleepers here, some different styles of fastenings, and you may say, "Oh, this house is a bit close to the railway line, and how can your front window be that far away from the railway? Surely it clatters." Yeah, it does. But this is actually realistic. There are plenty of places in London or Manchester and Liverpool. If you ride the train, you'll see that the railway literally goes past people's front windows and balconies. It's not that unusual. But here is a bit of a mess. The sleeper's missing. These are now wooden sleepers and they're sunk into the deck. The wooden sleeper should be a bit deeper than they are there, and they're just sort of sunk into the ground, which is, I can't tell whether that's concrete or wood or what, but obviously this isn't a realistic design. They've tried to put some wooden sleepers in here, probably for a bit of variety, which is good, but they should have kept with ballast. Ballast is the ideal thing to put under wooden sleepers rather than this sort of strange slab track where they've buried it in. And they've gone for spikes as well. The spikes on the base plates that are hammered in, these aren't actually anywhere near the foot of the rail, so they're not doing anything. They've just pinned the base plate down. So it's the other stuff, the concrete stuff, was better. I don't know if they started running out of time here or what, but um, it, it looks okay-ish from a distance, but with any degree of scrutiny, they would have been much better off with ballast. Plenty of wooden sleepers missing there, so those rails would just be free to move around, and the train would probably fall into the gauge there and derail. But as ever with Ubisoft, the railway details might be slightly off, but the actual big structures, the big bridges, are really well designed. This is an absolutely believable steel girder bridge. There are plenty of bridges like this. In reality, I see no issue with this design whatsoever. And if you go underneath and look at it, it looks plenty believable. The brick parts look okay. There's never anything much wrong with the civil engineering and the structures with these games, but the details of the tracks itself. And this where you've got shops and coffee shops and little bars and stuff like that underneath the arches, that's entirely real. There are plenty of bars and coffee shops and little places like that underneath these arches in London and in Manchester and various other areas. That's entirely accurate. So Watch Dogs then, final review. This game is what is leading me to think I should invent separate categories for these reviews. Not that these reviews mean anything anyway, it's just a bit of fun, really. But there's a large disparity in this game between the quality of the signaling and the signaling design and the track and permanent way stuff. Because the signaling, they've really made a good effort. They've got a nice variety of signals. They've not used all of them entirely right. So they've got a position light signal acting as a main signal where there isn't a turnout, little things like that. But for the most part, they've done a good job with it. I was quite impressed to see such a variety of realistic looking signals, and a lot of the times for the right functions. The signage in this game as well, top notch. A lot of these are proper signs. The ones surrounding signalling, the variable speed limits, the turnout speed limits, the direction stuff, the signage on the signals. They've got AWS and the limited clearance signs, stuff like that. So the signaling side of it, great, but the track, not so much. There's quite a lot wrong with the track that they could have fixed with a little bit of effort and just looking how a piece of switches and crossing is designed and having a points machine on it, little things like that. Obviously, I'm aware it's not conducive to gameplay whatsoever, and for the most part, I don't think much goes on the railway in this game because it's abandoned. I think that you might do a car chase there or something at some point, but for the most part, there's nothing up there. So they've really gone through more effort than they actually needed to. So I think because of the how good the signaling is and how not very good the track is, the signalling is probably going to weigh slightly more than the track. So maybe 6 out of 10, a generous 6 out of 10. Thanks for tuning in.